Suppose you want to update the account balance of a client when a payment is made. Okay? You write a little function. That little function goes to that client, takes the account balance of that client, adds the new payment, puts it back to the account balance. That's it. And that means you collected everything in one thing. If Excel was good in recursive calculations, actually, for example, there's a problem in option pricing. It's called valuation of American options. There is no closed form formula for those, even when there are no dividends. You have to create what we call a trinomial trees. And on each tree, on each branch, you have a little thing that's shaking around. That's the node. A node has value of the stock. What's the value of option at that node? What happens to the option value if you go straight, up, down, whatever? They're all in one places. If you had an object, all you have to do is define the object and define the rule between the branches. Then if you calculate the values on the very last nodes, all you have to do is ask for V00. It recursively calculates everything. But Excel is horrible in that. When you do a recursive calculation, basically the function calls itself. If you think about it, that's what recursive is. Whenever a code is executed, there's always something called garbage collection. The variables that were created during the computation have to be deleted from memory, and Excel is not good in that. I tried doing that for American options. I said, oh man, this is a beautiful code. Okay? All I have to do is write down the how you pass from one node to the other. I did it for 100 steps. You typically do about 1,000 steps, depending upon the length. It worked fine. I increased it 1,000. It took Excel 2 days to finish it. Unfortunately. For example, you can write a function for Fibonacci sequence, which is sequence now is equal to sequence before and the one before that, plus before that. It's ideal for recursive computation, right? But if you ask for the 5th number, no problem, you'll get it. Ask for the 1,000th number, you'll wait for 2 days. It shouldn't take that long. Anyway, so in this blank code, we're gonna write a function, and what do you know? We're gonna call that function, right? Let me see if I can make that bigger. Under Tools, Options, Editor Format. Let's make that font size 16. It didn't do it, I don't know why. And I can't simply zoom and show you bigger. That's one of the things Microsoft didn't think about. If I can zoom a regular screen, why can't I zoom this? I can't. Anyway, a function starts with the name of the function, and let's call this fixed bond price. Function names have to consist of contiguous characters. You cannot leave a space. If you want to distinguish between words, put an underscore between words. And how you capitalize that name does not matter at all internally. I mean, I made it F big, B big, and P big. I do that for 2 reasons. One, I like it. 2, more importantly, when you write code and you write that name within the code, how you capitalize doesn't matter. You can write the whole thing in all caps. You can write the whole thing in all small cases. Once you enter, spelling goes back to its original form. So if I write the code in all caps, And if it doesn't go back to that form, that means I have made a mistake spelling that. That allows me to catch those. And functions, as you know, have inputs. When you calculate a function f of x, you need to know what x is. You may have multiple inputs, and here our inputs are going to be, let's see. I'm going to call that cube rate as double. You don't have to explicitly type the variables, but it's always a good programming practice, because if I didn't type it, Excel is going to consider it a variant, which means it could take any form. A, it takes a lot more space in memory, and B, if instead of a number you put in a string, function will still think that, okay, there's nothing wrong. Double means a double precision real number, which is roughly means it is represented correctly in memory up to 15 significant digits. For most practical applications, you don't need anything more than 8. But if you're solving complicated differential equations in physics, you may even need more than double, because some of those things are very sensitive. And the second one is, I'm going to call that I rate as double. I'm going to let I rate represent yield to maturity. What else? I face as double. That's for face value. We have time to maturity in years. Again, that doesn't have to be an integer. And ifrec, that I'm going to make an integer. How many payments do you get per year, right? And I'm going to close it, and I'm going to tell Excel that the number you return is also double precision real number. Of course, Microsoft doesn't know anything about as, it knows about s, as. All right? It automatically placed a line that says end function. Anything I write between those two lines is the definition of the function. So I'm going to, first of all, it's a good programming practice to let the user know what this function does. That user may be 2 years from today, you may not remember what it does, but if you go to function definition, any line that starts with a single quote is a comment line. It is completely ignored during execution. It's just for information purposes. This function calculates value of a fixed rate bond at the beginning of a coupon period. Because if you're in the middle of a coupon period, it's a different thing. I'm not going to handle that, but you will actually get a homework assignment that's going to ask you to do it. And you can give information about what those things are. Coup rate is coupon rate. I rate is yield to maturity. I face is face value. I time is years, maybe non-integer. Left till maturity. ifrec is number of coupons per year, must be an integer. You can also make ifrec an optional argument. If it's left out, you can make it automatically 1. But I'm not going to do that here. If you come to my Excel class, I'll show you how to do it. Oh, I can't keep the whole store. This is more like coming attractions, okay? Now, there's going to be some variables that I'm going to create to make my life easy. They're called local variables. It is a good practice to declare them and type them. And you do that with a dim statement. Dim. For example, I'm going to calculate number of coupons. Okay. Oh. Dim